Okay, so let's do an example of analyzing a circuit in detail. So we have this circuit here, and we want to know what is the current through each resistor in this circuit. So the first thing we're going to do is we're going to label all of the currents, I total, I1, and I2, and we're going to use the technique of reduce, reuse, and recycle. So if you remember the technique of reduce, reuse, and recycle, the first step is to reduce our circuit to an equivalent resistor. And so let's identify a combination here that we can reproduce, which are these two. And so this is a parallel combination. So we can reduce our circuit to one that looks like this. To compute that equivalent resistance, we use the formula for resistors in parallel, which gives us an equivalent resistance of 5 ohms. Now we can continue to identify resistors we can simplify. So we see a series combination here. So we can simplify our circuit even more in terms of some new equivalent resistance. And this new equivalent resistance is given by the equivalent resistance of these two resistors in series, and so it's just the sum of the two. So we have an equivalent resistance of 10 ohms. Now the next step in doing reduce, reuse, recycle is to actually reuse. And in reuse, what we need to do is use Kirchhoff's loop law. And Kirchhoff's loop law says that the sum of the changes in potentials around the loop, if we start in some particular point, say in the bottom lower right corner, is just the sum of those changes in potentials. And that tells us what the total current is, and the total current is 1 amp. Now we move on to the next step, the recycle step, where we go backwards and find the current through each of the resistors. So to recycle, we have to rebuild our circuit backwards. So we go back a step to this circuit, where now the total current through the circuit is given by 1 amp. And the procedure that we need to do is identify what the voltage drop is across our equivalent resistor. And so we can find our voltage drop by taking current through that resistor times its resistance, and using Ohm's law, this gives us a voltage drop across this resistor of 5 volts. Now we move on to the next step in the circuit, so the circuit that we started with, so we rebuild that circuit, and again we put in this voltage drop that we now know across the parallel set of resistors. And we can use Ohm's law to find the individual currents through each of the resistors by taking the voltage drop over the resistance of that resistor, and we find that each resistor has the same amount of current as we would expect of half of an amp through it. So altogether, summarizing, we've found the current through each of the resistors, and the current through the 5 ohm resistor is 1 amp. Now before we finish up, let's check to make sure that this makes sense by using Kirchhoff's junction law. So we look at a particular junction, say this junction right here, and we look at all of the currents in and out of that junction. So Kirchhoff's junction law says that the currents in must be equal to the total current out. So the currents in are I1 and I2, and the currents out is just the total current. And we can check this. The total current into the junction is a half of an amp plus a half of an amp. And indeed, the total current out of the junction is 1 amp, so Kirchhoff's junction law works.